Imagine that the end of our universe might actually be the beginning of another one, perhaps one that's completely different from our own. This idea ties into the multiverse theory, which has been a topic of discussion among astronomers for quite some time. Now, there is emerging evidence supporting this idea. Recently, the James Webb Space Telescope delivered the first image of what could be another universe. Since ancient times, people have gazed at the stars, the sun, and the moon, trying to make sense of the universe. Early civilizations saw the sun and moon as portals to another world. Over centuries, we've learned that Earth is a sphere orbiting a star in a vast galaxy. And even though we've had powerful telescopes for over a century, much of the cosmos remains a mystery. While scientists have discovered answers to old questions, many more remain. Until recently, we didn't know if the universe had a beginning, an end, or was eternal. So far, our best telescopes have allowed us to see as far as 13.3 billion light-years away. The light that we observe with these telescopes, like the Hubble, shows us images from the distant past. Pictures of the universe as it looked when the light started its journey to us billions of years ago. This, looking back in time, has revealed much about the early universe, but the James Webb Space Telescope, which began operations in 2022, has taken this exploration to a whole new level. Even from its earliest images, Webb's findings have ignited debates among scientists. One key discovery is that there are 6 galaxies, like the one named Glass Z13, that existed just 250 to 350 million years after the Big Bang, a time when such massive structures shouldn't have existed according to current theories. At that stage, there should have only been a few stars beginning to form, not fully developed galaxies. This has raised serious questions about the Big Bang theory itself. One of the most fascinating images captured by the James Webb Telescope is of a galaxy cluster called MAX J0647+075. The image reveals what appears to be a group of old red galaxies, much more clearly than ever seen before. In fact, these objects were first imaged by the Hubble telescope a decade ago, but the quality of those images didn't reveal the stunning details that Webb uncovered. Using gravitational lensing, which magnifies distant objects, scientists have been able to see these ancient, bright, and highly organized galaxies in new detail. The unexpected brightness and structure of these galaxies have left scientists puzzled. If the data is accurate, these galaxies have produced far more stars than the Milky Way, defying all current astronomical models. Some researchers now believe that our understanding of the universe, built on the assumption of a single, coherent cosmos, may be fundamentally flawed. This brings us to the possibility of multiple universes, or a multiverse. For some time, theoretical physics has suggested that it might be more logical to assume that our universe is just one of many. These other universes could have entirely different physical laws and structures, and some of the galaxies we are observing might actually belong to one of these other universes. One of the newly discovered galaxies, called Glass Z12, existed only 300 to 400 million years after the Big Bang, making it incredibly ancient. But then, the discovery of another galaxy, CRS 93316, shook the scientific community even more. This galaxy existed just 250 million years after the Big Bang, but it also showed a bizarre anomaly. Its redshift readings, which indicate how far back in time we are looking, gave 2 different results. At one point, it appeared as though CRS 93316 existed in 2 places at once, as if it belonged to 2 different universes simultaneously. Scientists have humorously referred to this as the Schrödinger's galaxy, in reference to the famous quantum physics thought experiment by Erwin Schrödinger, where a cat in a box can be both dead and alive until observed. Similarly, CRS 93316 challenges our understanding of space and time. Could it be that we're looking at 2 realities overlapping, as suggested by quantum theories? While researchers continue to investigate these findings, they are hesitant to jump to conclusions. Some hope for measurement errors, while others wonder if these mysterious objects could even be galaxies at all. Yet, as more data comes in from the James Webb Telescope, it seems increasingly unlikely that simple explanations will suffice. One thing is clear: the discovery of CRS 93316 might just be the tip of the iceberg. NASA has suggested that this is only the beginning of a new era of discovery. As we delve deeper into the cosmos with the James Webb Telescope, we may soon find more evidence that challenges everything we know about the universe, or even reveals that ours is just one of many. The James Webb Space Telescope, JWST, has the potential to identify systems with a redshift greater than 20, indicating that these systems existed merely 200 million years after the Big Bang. This capability allows the telescope to peer further into our universe, suggesting that we may have encountered a boundary of existence that is irrelevant to the Big Bang narrative. Thus, we should no longer speak of the beginning of humanity, the universe, or the time following the explosion. Instead, we refer to it as the edge of the observable universe. At this edge lies another intriguing source of light, demonstrating an extraordinarily high redshift value. For instance, the galaxy known as 2744Y1 is indeed a universe whose light has traveled over 13 billion years to reach us. A team of researchers has utilized the world's best telescopes, including the Spitzer Space Telescope, Tundra, and Hubble, to capture a stunning image of this distant galaxy by combining data across various light frequencies. Not only is the age and distance of this galaxy astonishing, but its star formation rate also exceeds anything previously thought possible in physics. In fact, 2744Y1 generates stars at a rate several times faster than our own Milky Way, which is remarkable for a galaxy in a young universe. Currently, the observable universe has a diameter of 46.1 billion light-years, and beyond that, there is likely even more. As our technology improves, our observations can reach further and with greater precision. The JWST could potentially look back in time to 13.6 billion years, considering that the Big Bang occurred 13.8 billion years ago. However, there will eventually be a limit to our observations, as a few hundred years post-Big Bang, the universe would have been entirely dark. The first stars are believed to have formed only 380,000 years later, and if astronomers continue to discover much older galaxies, it could suggest that previous cosmological theories were incorrect. NASA scientists are already gaining initial insights from the JWST, which have been nothing short of extraordinary. However, time generally brings new discoveries, and in a few years, researchers might extract even more from the telescope's capabilities. This could potentially allow us to witness the events that occurred at the so-called beginning of time. Although the Big Bang theory seemed plausible for some time, there was no empirical evidence to support its accuracy. With the rise of quantum physics, it has become increasingly clear that our universe is an extraordinarily complex and variable place. Theories about bubble universes or pocket universes suggest that our universe exists within a massive bubble, sharing space with countless other bubbles of various sizes. The pocket universe theory posits that within a single universe, different regions may experience similar yet distinct states of being. There is an equal amount of evidence and clues for these theories as there is for the Big Bang hypothesis. The assumptions of the Big Bang and the principles of Einstein's physics were established long before the theories of quantum physics emerged. The integration of these models could lead to a deeper understanding of our universe and the concept of a multiverse. If the multiverse hypothesis proves to be accurate, we may find ourselves living in a bubble universe surrounded by other bubbles, or there could be an infinite number of universes, each governed by its own set of physical laws. This would imply a level of complexity that far exceeds our current understanding of the universe and our place within it. As we continue to explore and uncover new knowledge, the possibility of discovering alternate universes and perspectives becomes increasingly feasible, potentially reshaping our understanding of reality itself. Delving deeper into the implications of these cosmic revelations raises broader questions about our universe and our position within it. One of the most significant inquiries is whether the universe we observe is all that exists, or if our observations merely reveal a much larger and more intricate structure. The notion of a multiverse, where various possibly infinite universes exist beyond our own, has gained traction in theoretical physics and cosmology. If recent discoveries made by the James Webb Space Telescope indicate the presence of galaxies that defy current understanding, it could signify that our universe is just one fragment of a far grander infinite tapestry. The multiverse theory itself exists in various forms, each carrying different implications for our interpretation of reality. One notable theory is the inflationary multiverse, which suggests that during the early moments of the Big Bang, different regions of space expanded at varying rates. This uneven expansion may have resulted in the creation of distinct bubble universes, each with its own set of physical laws and constants. If this theory holds, the universe we observe may be just one bubble in a vast multiverse. Another fascinating concept is the cyclic universe theory, which posits that the universe undergoes an eternal cycle of creation, growth, contraction, and rebirth. According to this model, the universe we know could be the result of a previous universe collapsing on itself and then re-emerging in a Big Bang-like event. This cycle could theoretically repeat indefinitely, suggesting a continuous series of cosmic rebirths. The discovery of extremely old galaxies, such as Glass Z12 and CR 793316, presents significant challenges to our current understanding of cosmic evolution. These findings imply that processes may have occurred in the early universe that we do not yet fully grasp. If galaxies could form and evolve so quickly after the Big Bang, it indicates that our models of cosmic evolution and the formation of structures in the universe may require substantial revisions. Moreover, the possibility of observing anomalies that challenge standard models of physics opens the door to reassessing fundamental principles. For instance, the existence of galaxies with properties that question our understanding of dark matter, dark energy, and the behavior of light could necessitate a reevaluation of the standard model of particle physics. This might also prompt a re-examination of Einstein's theory of relativity and its application on cosmic scales. As we continue to push the limits of our observational capabilities, telescopes that surpass the JWST's power will be crucial. These advancements will allow us to probe even deeper into the universe and potentially detect more distant or faint objects. Such developments will help refine our understanding of the universe's history and structure, and may provide further insights into the fundamental nature of reality. Additionally, the philosophical and existential implications of these discoveries are profound. If our universe is part of a multiverse or if there are realms beyond our current observational boundaries, it challenges our fundamental understanding of existence. This could impact not only scientific theories but also our philosophical and spiritual perspectives on life, consciousness, and the nature of reality. As we unravel more about the universe, we may find ourselves reassessing fundamental questions regarding the significance and purpose of our existence. In summary, the new insights gained from the James Webb Space Telescope and other advanced observational instruments are expanding our understanding of the universe in ways we had not anticipated. These revelations are not only adding new pieces to the cosmic puzzle but are fundamentally reshaping our interpretation of the universe. As we continue to explore and learn, we stand on the brink of potentially profound discoveries that could alter our perception of reality itself. The journey to understand the true nature of the universe is far from over, and each new revelation brings us one step closer to unraveling the mysteries of existence.